In essence, it poses the question of why, in a universe full of planets and stars, we haven't found any proof of extraterrestrial life. One scientific fact that the James Webb Space Telescope is shedding light on is the immense immensity of the universe. In a recent research, the James Webb Telescope simulated an expedition to catch up with an interstellar object hurtling toward Earth and investigated in detail to determine its composition. What massive object did the James Webb Space Telescope discover? In what ways does size matter? Does this point to the existence of extraterrestrial life? Join us as we explore how the James Webb Telescope just intercepted a huge object heading towards Earth. On October 18, 1989, Galileo was aboard the Space Shuttle Atlantis as it blasted off from the Kennedy Space Center. Jupiter was the final destination of Galileo's scientific instruments, which it would use to spend years in orbit, taking photos and gathering data. But once it escaped the shuttle, Galileo went in the opposite way, swung around Venus to gain speed for its trip to the outer solar system, and then turned toward the Sun. As it traveled, it also circled the Earth twice, once at 597 miles and again at 188 miles. Engineers on board were able to put the craft's sensors to the test in this way. Carl Sagan, an astronomer on Galileo's scientific crew, dubbed the move the first flyby ever seen by Earth. It gave him the chance to think about what a spacecraft searching for intelligent life on a distant planet could find. There was much to observe. Our technological mess is fascinating. Littered metropolitan environments radiate heat islands and flashing lights. The current ebb and flow of atmospheric gases is demonstrated by the rising levels of carbon dioxide and methane, as well as the clouds of floating industrial waste. Radioactive leaks occur occasionally. Meanwhile, billions of devices and antennae emit a planetary swarm of electromagnetic broadcasts that buzz and whir. Would other planets' civilizations be like ours? Would they produce the same chemical and electromagnetic signals or technosignatures as Galileo found? Life is the common denominator of biosignatures and technosignatures. Just recently, when attempting to examine a recognized space rock in the main asteroid belt with the James Webb Space Telescope, this is what occurred. They discovered an asteroid instead, which is believed to be the tiniest object that Webb has seen thus far. The discovery proves that the telescope is quite sensitive when it comes to seeing the universe at infrared wavelengths. From a distance of over 72 million miles, the researchers detected the little photobomber, which measured 300 to 650 feet, or around the size of an aerial football field. If the asteroid is indeed that small, the telescope's mid-infrared instrument may end up being useful for future asteroid hunting, even though that wasn't its original purpose. Some were perplexed and dissatisfied that NASA utilized an illustration of the asteroid rather than a photo when they helped spread the word about the finding. The unexpected and fortunate discovery of such a small, feeble dot of light in pictures taken for an entirely different reason was truly remarkable. In the midst of the overwhelming visual chaos, it was challenging to make out the dot. In orbit around the Sun are millions of space pebbles. A donut-shaped area between Jupiter and Mars, the main asteroid belt contains the vast majority of these space rocks. However, so-called small asteroids, which are similar to this one, have received less attention from scientists due to the fact that they are more difficult to detect. Nearly parallel to Earth's fictitious orbit around the Sun is the main belt. Some of the earliest measurements used on the telescope aiming at this common plane were those taken by the team. Experts believe that even brief observations made by the Webb Space Telescope near this plane will inevitably contain some asteroids, the vast majority of which will be unidentified objects. Scientists are also trying to figure out how to best intercept extrasolar objects that whiz by our solar system, which could lead to up-close encounters with extraterrestrial beings. Spacecraft sent chasing after these galactic objects, with the ability to take pictures of them from as close as a few hundred miles away, could provide light on their makeup, history, and where they came from beyond our solar neighborhood. Just 6 years have passed since the first known extraterrestrial visitor, the enigmatic 300-foot-wide object Oumuamua, was discovered as it circled the solar system in October 2017. On top of being completely unique, Oumuamua was also an outlier that scientists couldn't understand, particularly due to its inexplicable and unexpected speed boost. The planet's transit signal is one of the most mysterious features. From Earth, we can see this light when 55 Cancri E makes a modest eclipse across its parent star's face and when the planet goes behind its star. As 55 Cancri E travels behind its star, its visible light output varies. At times, it is completely dark, and at other times, it is bright. Even if the intensity of an infrared signal varies, it is always present. Spitzer Space Telescope observations of that infrared light showed that the planet's day side was abnormally hot, reaching well over 4,400 degrees Fahrenheit, while the night side was somewhat cooler, at about 2,060 degrees Fahrenheit, but still hellish. New research suggests that the planet may be outgassing due to its closeness to its star, which would explain why massive volcanoes and thermal vents are erupting and releasing carbon-rich gases into space. But the planet's atmosphere can't withstand the intense heat for much longer, and the gas is eventually blown away, leaving the planet desolate until outgassing starts up again. On 55 Cancri E, the atmosphere is more prone to storms than on other planets. In an effort to thicken the atmosphere, the outgassing process is underway, but the star's intense radiation and solar wind are sweeping it away. But because there is an imbalance between these two processes, the planet's atmosphere can be present at some times and absent at others. Scientists think this atmospheric imbalance may explain the anomalous transit signals. The transit signal reflects the visible light and all surface radiation when the atmosphere expands. This is only a theory, but JPL provides a means to test it. Scientists could find out if a planet always has an atmosphere by measuring its pressure and temperature. We might expect to witness an increase in space-related scientific discoveries with the advent of powerful devices like the James Webb Space Telescope. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.